Hi Year 7, hope you're all well, having a lovely day. We're going to start our new topic today, which is going to be around area. Now just a quick explanation of where we're at. We're going to do the feedback from the retest you did yesterday next week, once I've had a chance to go through that properly. We've now done topics 1 and 2 in school. Topic 3 we started and did most of in school, and like I said at the start of last term, we're going to come back to that. Topic 4 we've now finished, so the obvious next topic would be obviously topic 5, but we're just going to rejig things slightly just because it's a bit easier to work with some topics in school and some topics not so much. So we're not missing anything or skipping anything, but we're going to do topic 8 now, and then we're going to come back and later this year we'll do topics 5, 6 and 7. So we're going to start with area today. So there are a few notes you need to make today. So the first thing you need to put is today's title, which is Area of Quadrilaterals. I'm doing this on the computer because I wanted to use some of the MyMath slides, but the title is Area of Quadrilaterals. So pause the video to get that in, and today's date, which is the 26th of February 2021. And have that in your exercise books. And there are sort of 3 key notes you need to make in your notes book today on topic 8, which is area. So we're going to look at 3 different quadrilaterals today. You don't need to make a note of this first bit. I'll tell you really clearly when you do need to make a note. This first bit you don't need to make a note of, but it's just a quick recap of what area is. I'm sure you've studied area before, but this is just a quick reminder of what area is. So area is the measure of space on a flat or on a 2D surface, as I'm sure you know. And when we first learned to measure area, and even now, even when we do the most fanciest of shapes, all we're really doing is a fancy way of just counting the number of squares that fit inside a shape. You could find the area of the most complex shape in the most complex method. Still, essentially, all it really is a fancy way of counting squares. And they can be any size of a square, but usually we do it to a unit. And the most common unit we use is centimetre, but obviously it can be any unit. And we call them centimetres squared or square centimetres. We can use square metres, we can use square anything. So like we said, when we first learned to calculate areas, we count squares. So if we wanted to compare these two, we could count the squares. Obviously we're not going to be doing lots of counting squares in secondary school maths, but it's important to remember that that's the principle of what we're doing whenever we calculate area. This one's bigger because it's got more squares that fit in it. So to start off with rectangles, we're proper mathematicians now, we don't want to be counting squares all the time, so we need to find more efficient methods. And I'm sure you've all done this with a rectangle before. In one row there are 4 squares, there are 5 rows with 4 squares in each, so we do 5 lots of 4. Now the first thing you need to write down in your notes book in page 8, and obviously I'm going slightly quickly so pause the video to get your note in, is this bottom bit here. The rule for finding the area of a rectangle is length times width, and you might put a little diagram in your notes book, I would as well. I often call it base times height, but length times width is fine as well. And if you want to put this one example of 4 and 5, you can. I'm sure you've done lots of areas of rectangles before. I don't want to dwell on that too much, but I did want to go through it because it sort of leads into our next ones. So pause that and make sure you've got a note in. Area of a rectangle is length times width. Put the example in if you want. Pause the video, make sure you've got the note in, and then come back and we'll go on to the next shape of 3 that we're doing today. Okay, so the next one we're going to look at today is a parallelogram. You may well have come across parallelograms before. It's a quadrilateral with any 2 pairs of parallel lines. So as it says here, rectangles and squares are technically parallelograms, but they're a subcategory of parallelograms. They have to have right angles too. They're more specific. But any shape with 2 pairs of parallel lines, any 4-sided shape with 2 pairs of parallel lines are parallelograms, and they often look a bit like that. Now, have a look at this graphic now, okay? We've got a sort of matching pair of rectangles and parallelograms. So you can see that the rectangles, and I'm going to change some things, but the rectangle and the parallelogram will always have the same base. and they will always have the same height. Now I'm going to change the base and change the height, and I'm going to change the tilt. Look what happens to the area of the rectangle, and look what happens to the area of the parallelogram. So I'll start by changing the base. I can obviously carry on changing the base as long as I want. Let's make it 9. I'm going to change the height and keep looking what's happening to the area. Now look what happens when I change the tilt. What do you think is going to happen? Maybe make a prediction in your mind. Do you think the rectangle is going to get bigger than the parallelogram? Do you think the parallelogram is going to get bigger than the rectangle? What happens when I change the tilt? Change it all the way down there. I can bring it back the whole way through. Whatever I change the height to, however I change the tilt, the area of the rectangle and the parallelogram stay the same. The area of that parallelogram is always going to be the same as the area of the rectangle that has the same base and heights. A lot of people like to remember it because if I look at this little triangle that's sticking out of the rectangle, if I were to cut that out, I could stick it in and it would fit exactly in this gap here. So it's the same as its sort of corresponding rectangle. Well, there you go, look, there's a little graphic that does it for us. So now we're going to see the note that we need to make. The area of a parallelogram is base times height, where the base and the height have to be perpendicular to each other. Perpendicular means at a right angle. So it's not just this length times this length, it has to be the base times the straight height, not the slant height. So do pause the video and make sure you make a note of that now. Little diagram and then the rule. And we're going to go through one of these together. Now you must make sure you've got a note of that rule. You don't have to have a note of this example, but I would strongly suggest you make a note of this example. So here's a parallelogram. To do the area, you need to do base times height. The base is 8 and the height has to be perpendicular, has to be at a right angle. So it's not going to be this slanty 7, it's going to be the straight, well, it obviously doesn't look very straight here, but it's at a right angle to the 8. It doesn't matter which is the base and which is the height. You could say that the height is 5 and the base is 8. Here it said that the base is 8 and the height is 5. But the key point is they're the two that's at a right angle to each other. 7 isn't at a right angle to either of them, so we can ignore that 7. So the area is 8 times 5, which is 40. So do make a note of that example just to help you. Pause the video if you need to. Okay, the last shape we're going to look at today, the last quadrilateral we're going to look at today is trapezia, or trapezia. Well, you could say trapeziums, but technically it's supposed to be trapezia. A trapezium is a quadrilateral with one pair of parallel lines. And again, it's related to the area of a rectangle. Trapezia can look really different. We often draw them like this, but obviously it could be rotated, it could be skinny, it could be wide. There's lots of different ways trapezia can look, but instead of having two pairs of parallel lines like the ones we looked at so far, it's just got that one pair of parallel lines. But again, it's linked to a rectangle. Have a look at the areas again. Notice now that my rectangle is sort of in the middle of my trapezium. So the heights are the same. The height of my rectangle is going to stay the same as the height of my trapezium. But notice that this width here on the rectangle is longer than the width of the trapezium, but then it's shorter than the width down here. So the width of the rectangle is sort of in the middle of the two different widths of the trapezium. So if I move these points, let's move it, let's not move it too much, so let's move it to there. We'll move this one to here. Or I can move this over, make it a different shaped trapezium, move these ones in. Or I can move them out again. I can make that one straight. I'll move this one in. You can keep playing with these, but notice that the